All right, so let's take a look. Once again, this is an application situation. Application of what would happen if we were going to look at the area to the right. So let's out to draw an image for this one. And that's something I didn't mention. It's really important to have that sketch so you can understand what you're actually looking at. So let's write down what we know. That'll kind of help us. So we know we're going to have a z-score. So we've got our x minus our mean divided by our standard deviation. So we might be given a z, we might be given an x, we might be given a mean, and we might be given a standard deviation. So as we're reading this, let's see if we can pull those things out. Each month an American household generates an average of 28 pounds. So there's our average of newspaper for garbage or recycling. Assume the variable is approximately normally distributed. There's my statement. Tells you that you can apply the rules. And has a standard deviation of 2 pounds. If a household is selected at random, find the probability of it generating more than 30.2 pounds of garbage. So there's my data value. That's the x. That's the quantity we want to compare to the parameters that are given. Parameters, remember, are population mean and population standard deviation. More than. Okay, well, let's come back to that in just a minute. Let's draw our picture now. Okay, so rough sketch. Then that'd be perfect, okay? So rough sketch, got my mean right smack in the middle. I wanted that to be blue. Got my mean right smack in the middle. My mean is 28. Okay, my data value is 30.2. I'm looking for the more than. I'm looking for more than is to the right. So this is what I'm looking for out here. But recall that my table E, when I go look at my table E is going to tell me the area to the left. No problem, right? We know what to do with that. We're just going to take that percentage and subtract it from 100. So let's go ahead and find our z-score. So our z-score would be 30.2 minus 28 divided by 2. So that's 2.2 divided by 2. That gives me a standard deviation of 1.1, or a z-score of 1.1. All right, let's take that and go to table E. All right, so here I am. I got a z-score of 1.1. So I go to my table, I do 1.1. So that's kind of a trick question, because what would be that number, that second decimal place? And if you said 0, you were correct. So I'd come here. So I'm looking at a corresponding percentage of 86.43. 86.43. So let's take that guy and let's go back to our page. So our corresponding percentage, excuse me, for the green area right here is 86.43, but we're looking for what's left over. We're looking for the blue over here. So remember that to find that leftover, we would take 100 minus our 86.43, and we take that, we come out with 13.57%. So we know that the percentage of the recycling that is greater than 30.2 pounds per month is 13.57% of the American households. Okay, so one more time. Of the American households, we know that 13.57% of the households have more than 30.2 pounds of recycling per month. Interesting, I guess, but that's the application, and that's what we use it for. So that's a greater than or more than problem.